Let's see what the inverse of a function is by the arrow diagram. So we'll let f be a one-on-one function from x onto y. So f of x, oops, just a second. So f of x is equal to y, right? The inverse of f is denoted by f inverse. It is a function from y onto x. Now it's the opposite way. So basically what that means is that f of, when you take this f to the right hand side, so f inverse of y is equal to x. F of x is equal to y, so f inverse of y is equal to x, right? X is equal to f inverse y. If and only if y is equal to f of x, right? That's just given, really. Now, and another thing, again, one-on-one function. That's necessary to remember. See, this is the diagram. F basically maps this x onto the set y, right? The terms in this set x onto the specific terms in y, right? So the opposite way around, when you need to map basically this y onto this set x, so values of y that will give you values of x, that is where you use f inverse, right? So basically the y set has the range of the function f, but it has the domain of the inverse function f inverse, right? But it is the opposite way around for this. In the case of the set x, the domain is of the function, but the range is of the inverse function, right? Says f inverse of y is equal to x, right? So the inverse function reverses the correspondence of the original function. That is what I told you earlier. F of x is equal to y, so f inverse of y is equal to x. Another very good example of this is that the sine function, right? You know that sine of x is equal to y. If sine of x is equal to y, you know very well that when you need to find x, you take sine inverse of y. That'll give you the value of x at that y point, right? So f inverse y is equal to x when f of x is equal to y. That's just simple. Now, let's have a question. Let's say that we have to find the inverse of a given function. We need to find f inverse of x when f of x is equal to minus 2x plus 8, right? Now, we know that y is equal to f of x, right? This f of x is equal to y. So x is equal to f inverse y, right? As we discussed earlier. Now, f of x is equal to minus 2x plus 8, which means that y is equal to minus 2x plus 8, right? But we need to find f inverse of y. So let's separate. F inverse of y is equal to x. So we need to separate the x over here in this equation to find f inverse of y. So you isolate x. First you take this 8 to the left hand side. So it becomes 8 minus y, and that is equal to 2x, right? You take this, actually not take this 8 to the left hand side, you take this 2x to the left hand side and take this y to the right hand side. So 2x is equal to 8 minus y, and then you take this 2 to the right hand side. So 8 minus y is now divided by 2. So now x is equal to 8 minus y divided by 2. So now, since x is equal to f inverse of y, replace this x with f inverse of y. So f inverse of y is equal to 8 minus y over 2, right? So simply what f inverse of x is, you just replace this y with x, like you did earlier for normal functions. Since f inverse of y is equal to this, now in every place where you have a y, which is just this case over here, you replace it with x. So f inverse of x is equal to 8 minus x over 2 instead of 8 minus y over 2. So that's how you find the inverse of a function.